Broadcasting live from SETI Alpha 6 in the Andromeda Galaxy, this is Mr. C.
Hey, happy Aloha Thursday to you. And sorry if you're getting some bright lights in your face. Remember, the top of my head is high albedo. That means reflectivity. So lots of light reflectivity off of it. So anywho, it's Happy Aloha Shirt Week. So my fourth Aloha shirt of the week. Tomorrow, Happy Aloha Friday, and then Thanksgiving week. That's the reason for celebrating with the Aloha shirts. Okay. Hey, I just wanted to take a little time to thank a number of you who have written me a little note. I really appreciate that. Like praying for you, miss you, that kind of thing. Thank you. I miss getting to see all of you face to face. It's a weird year. So 50 years of teaching up in front of students, and then 1 year of teaching behind the camera. I enjoy doing it, but I miss getting to be up front and seeing all of your smiling faces, or not so smiling faces, as the case may be. Anyway, I am praying for you and your families. I was last night, So just praying for God's protection and blessing on you and your families. And a couple of promises that I was thinking of last night for me personally, but pass them on to you as well. During this more trying time with COVID, I was thinking of an Old Testament verse where Jesus said in a number of places, when he told someone that he wanted them to do such and such, and then he said, "Surely I will go with you." Now, I was 12 when I asked Jesus to come into my life to forgive my sins. So I was born again when I was 12. So didn't change drastically immediately, but some during my junior high years and high school years, and then especially in my early 20s. The growth curve got more elevated. So thank you, Lord, for that. Anyway, surely I will go with you. I love that thought. So the Lord is going with us right now. And then Hebrews 13:5 says, I will never leave you nor forsake you. So he's never going to leave us. Once you ask Jesus in to forgive your sins, he's not going anywhere. He ain't going nowhere. He's there to stay. Now, for those of you who are just thinking about it, the idea of asking Jesus into your life to forgive your sins, it is such a wonderful and powerful decision. So I highly commend it to you, recommend it to you. Pray that you'll want to do it, because it will revolutionize your life. It might take a number of years, like it did in mine, but it makes such a difference to have all the wonderful benefits of being a Christian. And at the top of the list, knowing that we'll live forever in heaven with Jesus, that he's forgiven us, that he changes us to make us a person that he wants us to be, but more than that, a person that we enjoy a lot more, that has a lot more peace and joy, among other things. So there's just a little short recommendation on why wouldn't you want to become a believer? Why wouldn't you want to ask Jesus into your life? I don't get that. So anyway, but praying for you. So anyway, night and early morning observations, as a reminder, you can do these over Thanksgiving, and you can turn these in for the next several weeks. Remember, you've got the night sky objects, the ever-approaching Saturn on top of nearby Jupiter. And then in the east in the evening, you've got the beautiful Mars, It's just about as close as it gets every 2 years. So it's moving away a little bit, but it's still pretty close and pretty bright and pretty beautiful. So orangish Mars, so that's the evening. Oh, and by the way, tonight you've got the ISS. Remember, it's the second brightest object in the night sky when you see it. So the ISS has a 4-minute pass tonight from the south to the east at 5:46 p.m. So you might want to write that down. It's worth 5 points. 5:46 p.m. this evening, and a 4-minute pass. So anyway, pretty cool. So and then the early morning objects. So you've got Orion high in the southwest with its cross-like appearance if you dot to dot the stars, and then the 3 belt stars pointing down to the brightest star, Sirius, and then in the east the brightest object in the night sky except for the moon, Venus. So anyway, there you have all of that. Okay, I got rave reviews on a lightning round yesterday, so I'll do a lightning round for you. Just about Earth's moons. When you think of Earth's moons, what are 5 characteristics of the moon, of the Earth's moon, that you think of? It's about 1/4 in diameter, 1/6 the gravity. I'm just off the top of my head. So it's heavily cratered because it has no atmosphere. So the meteorites just slam into it at will. And then it's got the smooth maria where lava came across certain places and smoothed it out and made it darker there, and have hardened, cooled and hardened. So anyway, those are the major things about the moon. The moon is no atmosphere, and it's dry. Science of rockets. What laws involved with rockets? For every action, there's an equal and opposite reaction, and that leads to thrust in the other direction. And then you've got speed in a certain direction, velocity. If you get going fast enough to go in orbit, that's called orbital velocity. That's about 17,500 miles an hour around the Earth. Or escape velocity, where you can actually leave the Earth's gravity, but you've got to get going 25,000 miles an hour. So anyway, science of rockets, lightning round continuing, and then you've got all the things that we circled on the history of space exploration. And then you've got what space is like. It's a vacuum, no atoms, just no matter at all. A vacuum where everything is gone and it's just empty. And then space is also no gravity or microgravity. So, and then you've got your space spin-offs, things learned in space that we now use on the Earth, like memory foam, scratch resistant sunglasses, light but really warm outerwear, and LED lights, cordless vacuum cleaners, CMOS sensors, and on and on. Okay, models of the solar system. The Earth's the center, the first one that Ptolemy came up with about 1900 years ago. Earth's the center, geocentric, and then there's a sun-centered idea, heliocentric, popularized by Aristarchus, Copernicus, Tycho Brahe, and then finally Galileo, who really got famous for it. I'll probably ask you for a couple of those guys. What does a solar system include? The sun system. It includes the sun, the Earth and all the other planets, the moons. It includes asteroids, the asteroid belt, and it includes also meteorites, meteors, all of those included. Then you've got astronomical unit, the distance from the sun to the Earth. Astronomical unit, 1 AU, astronomical unit. So that was is LS11, and you've got LS12. What do all the inner planets have in common? You know, they're small. Because of that, they have a lot less mass than the outer planets. They've got, let's see what else, slow rotators, fast revolvers, few or no moons, no rings. So, and then you've got all of the matching characteristics that I'm going to let you look at on your own. So LS12, LS13, I'll come back to in just a minute, the sun, and then the outer planets, huge, made of gas, lots of moons, rings, and fast rotators, slow revolvers. So Mr. Gilbert in just a little bit is going to do telescopes with you. So I'll do a 2-minute break at this point, then I'll come back and do the sun and stars and galaxies. All right, I'm back. Okay, the sun. Okay, what is the sun like? The sun is kind of like our model star. Okay, actually most stars are smaller than the sun, we think. Okay, how many stars are there in the Milky Way galaxy? We think maybe 100 billion. How many galaxies or star clouds, other star clouds? We think maybe 100 billion. So 100 billion times 100 billion, it's actually a little more than that now. We think 10 to the 22nd stars. So what are stars like? So first, I wouldn't be holding a star like the sun on my lap. So what are stars like? They're made of gas. And it's gas that is incredibly massive and very dense. So the gases are packed tight, so made of gas. Here are the two gases the sun is made of, and we think lots of stars, are about 3/4, about 75% hydrogen gas. So 75% H, and then about 25% hydrogen. I said it incorrectly, helium, sorry. So 25% hydrogen, and I'm having my issues this morning, sorry. So about 75%. Here it is, get it right, Mr. C. 75% hydrogen, H, hydrogen, 75%. Got it. 25% helium, H, and then E. It's supposed to be an E. So 75% hydrogen and 25% helium. Now that's really important. So not an accident. The sun was absolutely designed, and other stars as well, or they couldn't do what they do. So they're made of gas. They're incredibly hot, super hot. The temperature in the sun, inside in the core, 27 million degrees. So 27 million degrees in the core. Wow. Did you get that down? 27 million in the core. Now on the surface, on the outer layers of the sun, we think maybe 8 to 10,000 degrees Fahrenheit. 8 to 10 on the surface. None of this is an accident, all designed, it's temperatures. So 27 million in the core, and then maybe 8 to 10,000 on the in the atmosphere, in the outer layers. Now, how is that heat generated? Here's how it's generated. So what's this? Hydrogen atoms, remember the sun is about 75% hydrogen. Hydrogen atoms, because it's so hot, are flying around super fast, and they smash into other hydrogen atoms and fuse together. So it's called fusion. So hydrogen fusion, and then heat and light are given off along with helium produced. So hydrogen atoms fuse together. So do it with me. Do fusion together with me in just a minute. Mr. Gilbert will lead you right there in front in the class. So it's hydrogen-hydrogen fusion, heat, light, and helium produced. Hydrogen-hydrogen fusion. All right, here we go together on the count of 3. 1, 2, 3. Hydrogen-hydrogen fusion, heat, light are given off, and then helium is produced as well. That's fusion. So I'll ask you several questions about fusion. So if I say to you, this would be a good explain question. How is the massive amounts of the light that lights up the solar system, lights up the Earth, how is that light produced? How is the heat that gets to the Earth produced? By fusion. Hydrogen, hydrogen. Here's a slow-mo version. Hydrogen, hydrogen. Fusion, heat, light, and helium, all produced by fusion. So probably at least 2 questions about fusion. So what is the sun like? Super hot, made of super dense gases. Which ones? Hydrogen and helium, causing nuclear fusion. And another thing happens too. Because of fusion, a bunch of invisible particles are sent away from the sun in every direction, toward the Earth as well. It's called the solar wind, and on LS13 you've got it down in 2 places actually, the bottom box and at the bottom of the top box. Solar wind, do you see that? Why don't you highlight it down in the bottom box as well. And in the top box there at the bottom, look what it says about the solar wind. Streams of electrically charged particles. They are fired toward the Earth and everywhere else in the solar system. When that solar wind gets to the Earth, we were given a divine design to block the solar wind from actually coming through the atmosphere at a number of places. It would be very harmful to living things, and it's harmful to our electrical systems that produce electricity and send it everywhere. In fact, a high output of these electrical charged particles can shut down our electrical systems, and have in the past. So anyway, but good news. Here's what happens. As they come into the Earth, the solar wind is blocked here and it's funneled around to the polar area where there's a magnetic field around the Earth that God designed to protect us from the solar wind. Couldn't be an accident. And as those electrically charged particles come in contact with the magnetic field of the Earth, it produces a lot of different colored light. And I'm having you look at that right now. You're seeing a photo of that. It's called the Aurora Borealis. And you're seeing a nice picture of it. There is also an Aurora Australis. Australis means south. So in the southern hemisphere, they also get an aurora too, but that would be Antarctica, and there just aren't, a lot of places near Antarctica that get to see it. Now, I think let's see, I got to get this right. I think Australia's southern state called Tasmania, they get an aurora once in a while, the southern lights. We get the northern lights, or Aurora Borealis. Raise your hand if you've ever seen the Aurora Borealis, where you get kind of like streams of ribbony light up in the atmosphere. Ever seen it? You have to be closer to the North Pole to see it in the northern United States or northern Europe. So I lived in North Dakota, so we saw the northern lights there, and once in a while, spectacular displays of the Aurora Borealis or northern lights. So my guess is those of you who raise your hand and that Mr. Gilbert can see with your hand up who have seen the aurora, my guess is you lived in a northern state, like Montana, Washington, Idaho, Michigan, Minnesota, New York, Maine. Okay, somewhere our northern, like, border states or up north. So anyway, did I miss anything on the sun? I did miss one other thing, that sometimes the sun will shoot out a huge prominence, kind of like an arc of solar energy. It's called a prominence. So it goes up from the sun like this. You're seeing it right now, the solar prominence. And then sometimes a huge amount of light is fired away from the sun. It's called a solar flare. And now you're looking at a solar flare that sometimes comes off the sun, and they're pretty spectacular. It says this energy heats the surrounding gas, causing it to erupt into space. So, and sends a lot of charged particles out. So, a prominence and then a solar flare. Prominence, flare. So that would make a good matching question. So anyway, I think those are the major things about the sun. Now, other stars are kind of like our sun, except a star's color is determined, its temperature, I should say, determines its color. For instance, the hottest stars, I might ask you this. So I wrote this down below. Blue stars are the hottest. Blue stars are the hottest. Reddish stars are the coolest. And when I say cool, they're cooler by several million degrees in the core. There's still millions of degrees in the core. So there you go. Blue stars are the hottest. Red stars are the coolest. I think Sirius is a reddish star. It's huge, way bigger than the sun, but it's cooler. Now, in between is a yellow star, and they're like medium hot. So in between, blue star's the hottest, yellow, and then red. And then just one other thing I want to tell you about stars. We can, and you're seeing a picture of this coming up right now, we can actually use an instrument and look at stars, put it on a telescope and look at stars, and we can get kind of a picture that shows a bunch of different lines, and those lines represent what kind of elements or atoms that star is predominantly made of. This is called a spectrograph. You're seeing a picture of it right now. A spectrograph. And you can see the lines on it. Some are thick, some are thin. So if you want to highlight this, on the stars, see this, characteristics of stars, on the stars lesson summary 14, you see what it says, a spectrograph, a device that breaks light into colors and produces an image of the spectrum. So we can figure out what elements it's made of, because each element has its own, it's kind of like an X-ray, like its own I'll say gram, that can identify the kinds of atoms, gases in that star. And then one last thing, God has spaced galaxies. Galaxies are just star clouds. God has spaced them where there are places in the universe, and we can see some of these, where there's a concentration of galaxies. You're seeing a picture right now of it's a deep space photo. I think it's taken from the Hubble telescope. And every little kind of like spot that you see there, you're looking at a galaxy. Oh, wow. Made of billions of stars, like the Milky Way, like Andromeda, the nearest galaxy to the Milky Way. Well, anyway, God has spaced those galaxies. They couldn't be an accident. He's put some in a certain area of the universe, and then wide areas where there's nothing. It's pretty much empty. Space is mostly empty, by the way. There's nothing between stars, hardly anything. Space is so immense. So you already know it's a vacuum. It's got no gravity. It's also immense. It's mostly empty. There's nothing in between stars, nothing in between galaxies. Just emptiness. I think God made it that way to reveal his greatness. He's so great and powerful. He makes this massive universe for us to look at. The heavens declare the glory of God. And we just go, wow, what a God. He spoke, hundreds of billions of galaxies into existence out of nothing instantaneously. My goodness. Praise to God, huh? So he is amazing. So you can add to your list of what is space like. I would do it if I were you. It's mostly empty. Okay? And there are hundreds of billions of galaxies. So it's mostly empty. And it's spaced. It's been spaced. Not an accident. Okay. So I'm going to turn it over to Mr. Gilbert. He's going to do a few things about telescopes with you that I can ask on the test. So I'll talk to you before the test tomorrow. See you then.